Let's go ahead and work out this integral. So I see I have a sine and cosine flowing around, which means you can come up with some U substitution. Play around with it, have fun. So I'm going to go ahead and choose U to be sine of Y. So the reason I'm doing that, because if this is U, then I see du is right here. That's why I'm going to go with that option. So that means du is going to be cosine of Y dy. And that's exactly what I have here. So the integral now can be replaced in terms of this new variable, u. So I can write this as the integral of, so cosine y dy, that's our du. And sine is u, so this will be u squared, because this is sine squared. Then plus sine, which is again u, minus 6. All right, so that looks like a polynomial now. Now here you can use partial fractions. So on this step, we can set up our partial fractions because we have a polynomial of degree 0 on top. Think about it as 1. And on the bottom, you have a polynomial of degree 2. If you want, you could actually complete the square, but I'm going to go with partial fractions since that's what I feel like doing in this integral. So let's go ahead and do that. Break it up. So I can write this as some a. Well, actually, let's not do that yet. Let's factor the denominator. So I have 1 du over, I can factor the denominator into u plus 3 and u minus 2. Those are the factors for u squared plus u minus 6. All right, now I can break it up. So I have the integral of a over u plus 3 and then plus b over u minus 2. Since they are linear factors in the denominator, we put constant on top in respect to du. So now let's solve for our a and b. So I'm going to set this side equal to this side and ignore the integral symbol since we're just solving for a and b algebraically. So we have 1 is equal to a times u minus 2 when you multiply both sides by the least common denominator, plus b times the denominator u plus 3. So that's the equation we get when we multiply the whole thing by the LCD. And now let's choose values for u to solve for a and b. So I'm going to go ahead and choose u to be, let's say 2. If I pick u to be 2, then this will go to 0, which will enable you to solve for your b constant. So you have 1 on the left side is equal to b times 2 plus 3, that's 5, which implies that b is equal to 1 over 5. So that's good. We got one more to go. So I'm going to choose now I want to make this factor 0. So I'm going to pick u to be negative 3. So if u is negative 3, I have on the left side 1 is equal to a times negative 3 minus 2, that's negative 5, which gives me a is equal to negative 1 over 5. All right, that's wonderful. And now I'm ready to integrate. So I'm going to go ahead and replace those right up here for a and b. So let's copy this again. So our integral becomes the following once we replace our unknowns a and b. So we solved for a and b, and we got a is equal to negative 1/5, and b is equal to positive 1/5. And now integrate this. So the integral of the first one, you can pull out the constant negative 1/5. So you're really integrating 1 over u plus 3 du. And for the second one, I'll do the same thing. I'll pull out the 1/5. I'm integrating 1 over u minus 2 du. So this integral right here, that's ln of u plus 3, because if you do a substitution, you'll end up with ln. So our final answer is 1 negative 1/5 ln of absolute value of u plus 3 plus, now this integral is also ln because it's u minus 2 on the denominator, linear function. So this is 1/5 ln of absolute value of u minus 2 plus c. So we finish integrating. Now let's bring back what u is. So initially, we said that u is equal to sine of y. Let's replace that so we can go back to our original variable. So u is sine of y. So this is negative 1/5 ln of sine of y plus 3 plus 1/5 ln of sine of y minus 2. So this is sort of like our final answer. But if you want to be clever and want to rewrite the answer in a different way, since we see logarithms, and I can play around with this a little bit more. So I'm going to go ahead and have fun with this answer. Rewrite. So I can pull out a 1/5. So you have 1/5 times. Now, since this has a negative, I'm going to let that come second. I'll rewrite the positive term first. So you have ln of sine of y minus 2 first, and then the minus ln of sine of y plus 3 plus c. And then I'm gonna, since I see a subtraction between two logarithms, by laws of logarithm, that turns into a division. So you have 1/5 ln of sine of y minus 2 over sine of y plus 3 plus c. So that's another way to express the same answer, just playing around with laws of logarithms. All right, I hope this helps. See you next time.